Hi, this is the second part of Introduction to Graphing Polynomials. When we left off, we graphed this y equals x plus 4 to the third power and saw that we had an inflection point. I wanted to continue because you might have questions of, hey, well, what goes on at the other powers? So let's look at real quick x minus 2, and we'll raise that to the fourth power. Now, what you're going to find out is that, well, once we find our root, or our x-intercept, which is positive 2 here, that the 4 is going to act very much like the second power. And that is, we're going to bounce off of this root. So we're going to start here, and we're going to approach that point. And when we get to it, we're going to bounce off of it. Okay? And then that's really what happens when you get to a fourth power. And the funny thing is, it's exactly what would happen if you would have approached any point that was an even power. Any even powered function will bounce off of that root, just like that. So we'll talk about that more in depth, but for a general rule, if it's even power, you're going to see this sort of behavior where we bounce off of a root or an x-intercept. Again, if we look at the last example we had in part 1, we had something like x, and I can't remember the number, but I think it was like 4, yeah, I think that's what it was, to the third power. Well, we went out here to 1, 2, 3, 4, and as we approached that point, we sort of changed direction. And that's a much better looking graph than we had in the previous example. What you're going to find, though, ladies and gentlemen, is that this would have happened if our root here would have been 5, okay, or if it would have been 7, and you guessed it, if it would have been 9. Say, well, Mr. Martinez, why don't you just say y equals x plus c to any odd power? We'll do this inflection. The reason why I don't say that, ladies and gentlemen, is because remember what happened here when we had it raised to the 1 power. It didn't inflect, it just went straight through that. So if we were going to make a general rule, what I would say would, it inflects through all odd powered functions that are odd numbers greater than 1. Because at 1, we just go straight through the point. In the next part of the video, we're going to talk about how this odd function seems to start in the third quadrant, whereas these even functions seem to start in the second quadrant. And we'll talk about that a little bit and exceptions to those rules. Okay?